Have you ever wondered how some things just seem to explode? They grow so fast it feels like it happens overnight. Well, today, we're going to pull back the curtain on the powerful mathematical engine that drives that incredible change. We are talking about something called geometric progression.
So here's our game plan. First, we'll look at the basic pattern of change. Then we'll decode the simple formula behind it. We'll explore its two different sides, growth and decay. And then we'll find it out in the real world. And finally, you'll see how to spot this pattern just about everywhere. Okay, let's dive right in. Part 1, a pattern of change. This is all about that hidden engine behind explosive growth. So let me ask you a question. What on earth could your savings account, the way populations grow, and a video going viral all possibly have in common? They seem completely unrelated, right? But there's a secret connection. And here it is. It's all about multiplication. See, it's not about adding a little bit more each time. It's about multiplying what's already there. Every single step builds on the last one, and that's what leads to that rapid, almost unbelievable change we see.
All right, section 2, the core formula. Now that we know what it is, let's start decoding the language of how it all works. So here's the official name for our pattern, geometric progression, or GP for short. And the key idea is right there in the definition. It's a sequence that's built by multiplying by the exact same number over and over and over again. Simple as that.
And you know what's cool? To build one of these, you only need 2 key ingredients. First up, you need A, which is just your starting point. And second, you need R, the common ratio. Just think of R as your multiplier. It's the growth engine that powers the entire thing.
Now, I know this formula might look a little intense at first glance, but honestly, the recipe is way simpler than it looks. It's really just saying this. To find any term down the line, you just take your starting point, A, and you multiply it by your growth engine, R, a certain number of times. That's all there is to it. In fact, you can basically forget the formula for a second and just think of it as these 3 simple steps. 1, pick where you start. 2, pick your multiplier. And 3, just let it run. Multiply your first number by R to get the second, multiply that one by R to get the third, and just watch the pattern unfold. Okay, next up, growth versus decay. Because that little growth engine we talked about, R, actually has 2 very different faces. And here's the rule. It's super simple. If your multiplier R is any number bigger than 1, could be 2, could be 1.5, even 1.01, your sequence is going to grow, and it's going to grow fast. But if R is a fraction, something between 0 and 1, like a half or 0.9, the sequence will actually shrink, getting smaller and smaller, closer and closer to 0.
Let's look at this in action. It makes it so clear. On the left, we're starting with 1, and we're just multiplying by 2 each time. You can see in just 4 steps, we're already at 8. Now, on the right, we start at 100, but we multiply by 0.5, which is just like cutting it in half. See how fast it shrinks? It's the exact same process, but with completely opposite results. And it's all decided by that one number, R.
So, section 4, GP in your world. Because this is not just some math theory, okay? This pattern is absolutely everywhere, from your bank account all the way to the natural world. Compound interest is the classic example, right? Your money gets multiplied by a number just a little bit over 1 each year. Radioactive decay is the flip side of that. A substance gets multiplied by a fraction, causing it to shrink over time. But you see it in population growth, in savings accounts, and even in these beautiful doubling patterns you find in nature, like in ferns or seashells. It really is everywhere. Which brings us to our final section, seeing the pattern everywhere. So after all of this, what's the big takeaway? Why does understanding this one simple pattern matter so much? Well, it really all boils down to this. Geometric progression gives us the tools to understand and even predict really rapid change. It's the key to seeing how small, consistent multiplications can lead to absolutely huge results over time. So whether we're talking about the incredible growth of an investment or the steady decay of a substance, this pattern is fundamental. It's the hidden language that describes how things get big, fast, and how things fade away, all through that simple power of repeated multiplication. And that's the real challenge, isn't it? This pattern is out there right now, in finance, in science, in technology. So the question I want to leave you with is this. Now that you know the secret of exponential change,
Where are you going to see it next?